Okay, so what I'm going to do now is do the answers to question 1 to 11 on the linear demand worksheet. I'm going to split this because this is quite a big worksheet, so I'm going to split it up into different videos. So the first one is just questions 1 to 11. Okay, so the first question is define the term demand. And what demand refers to is the quantity of a good or service that consumers are willing and able to buy at different prices. And then that leads on, the fact that it says it's different prices leads on to the next question, which what is the law of demand? The law of demand states that ceteris paribus, don't forget what that means. A Latin term always used in economics mean all other things equal. Nothing else has changed but what I'm about to say now, which is price. The law of demand states that ceteris paribus, an increase in the price of a good or service leads to a decrease in the quantity demanded of that good or service and vice versa. So as price goes up, people buy less of the good, the quantity demanded goes down. This is a movement along the demand curve. And as the price goes down, people buy more of that good or service and the quantity demanded goes up. So price and quantity demanded, when we're talking about demand, of course, move in opposite directions. Now, question 3 said, in the box below, draw an outward shift to the demand curve. And I'm trying to get to the maths and stuff like that in these kind of videos, but what I do want you to see here is that I've labeled a price, I've labeled a quantity, we've got D1, D2, and I suppose I probably should have put a title here, which is just demand curve, okay? So don't forget titles are important as well, right? Now, I hope I'm not going too fast, but there's the definitions and one graph, and now we're on to the second one, which is an inward shift in the demand curve. Maybe before I move on, what this means is that at every price, and I know it's not every price, okay, but at every actionable price, consumers are willing and able to buy more of this good. There has been an increase in the amount that consumers wish to buy, and they also have the necessary purchasing power with which to afford to buy it. Now, an inward shift in the demand curve, I'm going to write here demand curve, okay, demand curve or inward shift or whatever, okay, just the title, price, quantity. Okay, we can get rid of that. Or maybe we can't. I'm moving on. Price, quantity. So all we're saying is that at every price, let consumers buy less than they did previously. Consumers want this good for whatever reason or are able to afford it less than they were previously. Now, name and explain 6 factors that cause a shift in the demand curve, right? Well, we're using the ones from Jason Welker, which is TOIS. Okay, so it's TOIESS. Okay, so the T stands for taste and preferences of consumers. If consumers wish to buy more, for whatever reason, has become more fashionable, has become more desirable, has become more in vogue, then consumers will buy more of it. That's an outward shift in the demand curve. If for whatever reason, and I used the example in class of salmonella scare, which is a poisoning in eggs, or BSE, is also called mad cow disease in beef, then there would be an inward shift because people were afraid to eat those things because they'd get sick and maybe die. So there would be an inward shift and people would be buying less of it. Other related goods prices, so the price of other related goods, okay, so there are 2 types of related goods. There are substitutes, which are goods that are used to fulfill the same function as a good in question, and the famous ones are like Coke and Pepsi, any type. I mean, I'm Irish, so I'll use Daz and Radion. They're both clothes detergents, stuff like that, okay? Those things are substitute goods. They fulfill the same function as a good in question, all right? So they're easily, not to use the word I'm defining the definition, but easily substitutable. Consumers are somewhat indifferent by a large extent between consuming one or the other. They don't really mind. So if the price of a substitute good falls, right, and we're talking about, so let's say, what example did I give? So the price of Coke falls, what happens to the demand for Pepsi? Okay, well, if the price of Coke falls, Coke is cheaper. These 2 goods fulfill the same function as the good in question, as each other. So the demand curve for Pepsi will shift inwards as consumers substitute Coke for Pepsi, or substitute away from Pepsi in order to buy more Coke. And the opposite will be true. If the price of Coke rose, then this is the demand curve for Pepsi, that would shift outwards. Okay. Now the next thing is there are complementary goods or complements, and what these goods are goods that are used in joint demand. Okay, you have to use them both in order to enjoy the experience. So if you want to drive a car, and assuming it's not like a Tesla or something like that, it's one that runs on petrol, you need, in order to drive, you need petrol and a car. Okay, if you're, someone unfortunate enough to be a smoker, in order to smoke, you need cigarettes and you need a lighter. There's loads of other examples, but if the price of if a complement, rises, so if, what happens to the demand for cars if the price of a complement rises? Well, the whole driving experience now becomes more expensive, and as such, the demand for cars fall, and we'd have an inward shift in the demand curve like we have here. I'm in 2020, unfortunately we're still in COVID times, so the demand for petrol has absolutely fallen. That has led to a fall in the price of petrol, okay, and therefore the idea would be that the demand for cars would rise. Now, I'm not 100% sure if that's happening, because I don't think anybody's spending any money at the moment, for a reason that we're about to come to. Okay, so expectations regarding future price. Now, if consumers expect the price of a good will fall in the future, they will consume less of that good today in order to be in a position to avail of the cheaper prices or buy it at the cheaper prices in the future. If consumers expect the price of a good to fall in the future, that will cause the demand curve to shift inwards today. That means consumers will buy less today and more tomorrow, or whenever the price becomes cheaper. And they're not necessarily right, it's what consumers expect to happen. If, on the other hand, that they expect the price of the good to rise in the future, then that would most likely cause an outward shift of the demand curve today, as consumers don't wish to pay the higher price that they expect to be charged in the future. Now, changes in income. I won't go into too much the difference between normal goods and inferior goods. I'll just give a quick definition. Normal goods are goods that you buy more of as your income rises. Okay, so and this changes, and I've done a whole video on that. But basically, you as your income gets higher and higher, you stop taking the bus and you buy a car. Okay, so as your income rose, the car is a normal good. So if income rises, the demand for normal goods rises, and this causes an outward shift in the demand curve. Okay, if income rises, the demand for inferior goods fall. So inferior goods are goods with a negative income effect, and these are goods that you buy less of as your income rises. And the example of the good that you bought less of, and the one that I just gave, was the bus journeys. So as your income rises, people tend to buy less bus journeys. And why is that? Because they've now bought a car, because their income has risen, and they don't require bus journeys anymore because they now have a car and they drive to work. In that scenario, the inferior good is the bus journey. Okay, you buy less of it as you get richer, and then what happens if they lose the job? Well, most likely they sell the car and they're back on the bus, and you buy more inferior goods as your income falls. You buy less normal goods as your income falls. Now, the next two I would hope are relatively straightforward. Okay, so we've got the size of the market. If more consumers enter the market, if, let's say, through immigration, there's a lot more people in the country, well then, by and large, the demand for all goods would rise. Now, we're not talking about macroeconomics, which is later on this academic year. We're talking about microeconomics now. So if, for example, there's a lot more immigration into a country, or I'm Irish, as I said, so from Dublin, we had a huge amount of immigration into Dublin from other countries, and that meant that the demand for houses and housing, like apartments and stuff like that, rose a lot, okay? And that was because there was simply just more people there. Also, we had a lot of people that weren't from Dublin, in counties around the whole country, moving to Dublin to avail of better working opportunities or job opportunities, or the ability or the opportunity to find other jobs. That also put pressure on the housing market. And what do I mean by put pressure on the housing market? It increased the demand for housing, okay? Now, the last thing that causes a shift in the demand curve, and don't forget there can be inward shifts and outward shifts, while I adjust my pages, are special circumstances. So the example that I always use is on a very, very hot day, the demand for ice cream or cold drinks or something like that will rise. That will cause an outward shift in the demand curve. It's a special circumstance. You can't plan it, you can't guarantee it, you're not 100% sure when it'll happen, but still, it will affect demand. Okay, on a very, very rainy day, there will be a much lower demand for ice cream. As I said in my other videos, it really doesn't bother me, the temperature. I'd eat ice cream at any temperature. But for most normal people, unlike myself, a very cold day would most likely cause a reduction in the demand for ice cream. Now we're getting onto a bit of the mathematics, and this is really important that we understand what we're doing here. Okay, so this is a demand function, and I do say linear in that it's a straight line, but we'll see that later on in this video. Consider the demand function. The quantity demanded, the amount of a good that consumers will buy, equals 100, which is the A variable. Talk more about that, okay? It's the where it cuts the I'll get more about that later. Minus 4p, okay? Calculate the quantity demanded at the following prices. Well, the first thing you always do is write down the formula, okay? You're going to write down the equation. Now, price, we know in this scenario, is 10. Okay, so we're trying to find the quantity demanded, and we know the quantity demanded equals 100 minus 4 times the price. But now, instead of P, we're going to write 10 because we were told the price equals 10, and this is the price. So we have QD equals 100 minus 40, therefore QD equals 60, and I'm just going to write 60 down here. Okay, again, the first thing we always do, and get into this habit, do not get lazy, is we write down the equation. We're trying to find the quantity demanded. We know the quantity demanded equals 100 minus 4 times the price. The price in this case is 5, so the quantity demanded equals 100 minus 20, and therefore 100 minus 20 is 80. So what we are saying here is if the company charges a price of 5, they will sell 80 units. That's exactly what we're saying, okay? Now, notice that the price fell. What happened to quantity demanded? It increased. That's all the way back to question number 2, which is the law of demand. And again, I don't care if I'm kind of annoying you in this regard, get into this habit. Write down the equation. So the quantity demanded, we were told, because of this linear demand function, equals 100 minus 4 times the price, and the price is 15 here. Forgive me if I'm squiggling. So it's a 100 minus 60, because 4 times 15 is 60, equals QD equals 40. Now again, let's compare it to 10. The price went up, and what happened to quantity demanded? Went down. Okay, so that's the law of demand, and we should expect that. Okay, now on to the next question. Okay, question 7. Consider the demand function QD equals 200 minus 2p. Calculate the price at the calculate the price at the following quantity demanded. You must forgive me, lads. That should say calculate the quantity demanded at the following price. So again, QD equals excuse me. It shouldn't say that. Okay, but I'm still going to write it down. QD equals 200 minus 2p. Now, in this case, so I'm forgetting myself here, and I better make sure that you can see the question. In this case, we are given the quantity demanded. Now we're trying to calculate the price. So the quantity demanded is 150. So instead of quantity demanded, I'm going to write down 150 equals 200 minus 2p. Now this is slightly longer, okay? Now there are different ways to do it, all right? I would argue the easiest way is to flip 2 numbers at once. Forgive me if that confuses you, but I think most of you should be up to that level and relatively comfortable. So if I bring this minus 2p over here, that becomes plus 2p, because I brought it over the equal sign. That means I change its sign from a minus to a plus. If I bring this plus 150 over the equal sign to here, it becomes a minus 150. Now, we've got 2p equals 50, but that's not the answer, okay? We know what 2 times the price equals. We want to know what just 1 times the price or the price equals. So I'm going to skip down here. I'm going to write 2p equals 50, and then a little bit of algebra. You divide both sides of the equation. You can do whatever you want to one side of an equation as long as you do the same thing to the other side. Both sides of the equation by the number before the letter we're trying to find. Well, we're trying to find p. The number before that is 2. So 2p divided by 2, or half of 2p, these will always cancel. You're simply left with p equals 50 divided by 2 is 25. So at a price of 25 euro, dollars, pounds, yen, I'm in Mongolia at the moment, so Tugrit, at a price of that, 150 units would be sold. Now, onto this. So again, QD equals 200 minus 2p. Quantity demanded is 100, so it's 200 minus 2p. I'm going to bring the price over here, which is 2p, goes from a minus to a plus, equals 200 minus 100. We get 2p equals 200 minus 100 is 100. And then we go down here, 2p equals 100. Divide both sides by the number before the letter we're trying to find. These two cancel, and we're left with p equals 50. Okay, so 50. And look at this. As price rose, quantity demanded fell. Okay, so again, law of demand, and we should expect this. This actually all comes from this minus b here, just so you know. Okay, now the last one is Q. Well, it's not the last one in this video. So QD equals 200 minus 2p. Okay, 50 equals 200 minus 2p. Bring the minus 2p over. We get 2p equals 200 minus 50. 2p equals 150, because that's 200 minus 50 is 150. So don't forget, if 2p equals 150, well, what does 1p equal? Well, we're going to have to divide both sides by the number before the letter we're trying to find, which is p, and that's 75. So as price rose, quantity demanded fell, and we should expect that. Now, that's that one. Okay, I'm not going to rush myself at all, but I'm going to try to be as efficient as possible. Okay. Now, the next thing we have here is consider the following demand function for Mongolian beef, okay? Something that I absolutely love, is very close to my heart and very good at clogging my heart, I'm sure, okay? Where quantities are measured in kilograms. QD equals 200 minus 3p. Okay, so it says find the quantity demanded at each of these prices. Now, the first thing I want to do is, again, boring me over here, I'm going to write down the equation. Okay, now this is what I want you to keep in mind, that here it says 200. I'm asking at a price of 0. Now, some of you can see it straight away, others mightn't. So minus 3 times 0. QD equals 200. Now, if you're honestly unsure, and some people are just really low confidence at maths and they like to use their calculator for everything. Okay, well, that's absolutely fine. So if you're unsure, put it into your calculator, but I'm telling you now it's minus 0. So QD equals 200 at a price of 0. What we're actually saying here, if this good was free, people would take 200, because they're not buying it, they're taking 200. And that kind of shows the law of diminishing marginal utility, which is one of the reasons that the demand curve is downward sloping. People aren't going to take infinite amount, even though I have said in the past that people have infinite wants but limited income. Now, I'm going to continue on. I'm happily going to continue on, okay? And I'm just going to do every single one. So the next one is 10, okay? So QD equals 200 minus 3p. QD at a price of 10 now, we're trying to work out what the quantity demanded is, equals 200 minus 30. QD, and I hope I'm not going too fast, but I am trying to be efficient. Okay, so what we've got here is at a price of 10, it's 170. Now I will continue on, but look at this. This says minus 3. Remember that. That's the slope of the demand curve when we draw it. And then these are going up by 10. So if the price is going up by 10, what do we expect the quantity demanded to fall by? Well, it's 3 times the change in quantity. Okay, I'll do another, just one, and then I shall kind of extrapolate from there the answers. Okay, the rest of them. QD equals 200 minus 3p. And again, if you're unsure, do not do what I've been doing, okay? Like, do not do what I'm about to do in a second, because I've been doing this for years, all right? So, and I'm the teacher. You would hope that I would know it and be very comfortable with it, okay? It doesn't mean I can't make mistakes, of course. I'm more than liable to do that, okay? But if you're unsure, just take your time and do all the maths. You'll have loads of time in the exam. 3, and we're working at a price of 20. So QD equals 200 minus 60. QD, 200 minus 60, I believe is 140, and I think I'm right to believe that. Now look at this, 140. Now the reason that we can do this, and maybe I will just continue on, but I'm telling you now, because this is a minus 3, this slope tells us, the number before P tells us how much quantity demanded will change when price changes by 1. Okay, so if price goes up by €1, quantity demanded will fall by 3 because it's minus 3, which shows it's a downward sloping demand curve consistent with the law of demand, times the change in price, shall we say. But look, I'll keep on going anyway just for completeness. So again, QD equals 200 minus 3p. QD equals, QD equals 200 minus 3 times 30. QD equals 200, 3 times 30 is 90. QD equals 110. Let's examine the pattern, right? 110. The prices go up by 10 and each of these quantities are falling by 30. Why is that? Because this is the slope. This is how much quantity demanded changes when price changes by 1. The number before P tells you how much quantity demanded changes when price changes by 1. $1, 1 togrit, 1 euro, whatever. Okay? But I'll keep on going on just in case anybody is struggling. And if you're not struggling, feel free to just skip ahead on the video. Okay? It's 200 minus 3p. QD, now we're looking for a price of 40. It's 200 minus 3 times 40. QD equals 200 minus 120. QD equals 80. Are we noticing a pattern? Yes. All of these are going up by 10, but don't forget the number before the P is the slope. Now technically it's the inverse of the slope, but I'm not going to confuse you with that. We're going to say it's the slope, and it's how much quantity demanded changes when price changes by 1. Here it's changing by 10, so we multiply it by 3 and we find that we're going down in 30s. QD equals 200 minus 3p. QD equals 200 minus 3 times, what are we on now, 50? QD equals 200 minus 150. QD equals 50. Has that gone down by 30? Yes, it has. Why? The number before P is the slope. This is another important number. We'll talk about it now in a second when we draw the graphs, but both of these are important. This is A and this is B. Okay, and the last one, just for completeness sake, we might as well do it. 200 minus 3p. QD equals 200 minus 3 times 60, right? Yeah. QD equals 200 minus 180. QD equals 20. So at a price of 60, 20 is bought, and I've already said the reason that they're going down in 30s is because the price is rising by 10, and this number here, the minus 3, is how much quantity demanded will change when price rises by 1. It hasn't risen by 1, it's risen by 10 in every time, so we should expect a 30 unit reduction for every time price rises by 10. I hope that makes sense. Now, we're on to a bit of awkward stuff here, right? So what's the first thing it says now? Question 6. Okay, well I have question 6 here. Excuse me. And I'm just going to keep on going until my battery dies. So we'll see how far I can get. I have question 6 here, right? So I've got at a price of 10, at a price of 5, and at a price of 15. So I need to make sure that these prices are on the line. 5, 10, and 15. You'll see what I mean in a second. And I need 40, 80, and 60. So what I need to do here now, what I'm going to do is I'm going to go up 20. So here's 1 for every 3 boxes. This is the quantity axis. 24, 60. So I'm going to go up 10, 10, 20, 30, 40, 50, 60, 70, 80. Okay, now, and then I'm going to go up, I don't know what I'm going to go up now. I'll probably go up and need to get up to 15. So let's see. 6, 8, 10. Just going to go up in 2s and see how far I can go. These could be 1s. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so what I'm going to do now is, oh God, I'm sorry, you couldn't see the bottom there. Okay, I do apologize, guys, all right? So I'm going to do now is just, this is a price of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, I did say I was going to get to question 11. I don't think I will because of battery issues, but hopefully we can, I'll get to the end of this question before my laptop dies. All right, so what's this now? Question 6 we're looking for, silly me, this one here, right? So at a price of 10, the quantity demanded is 60. So I go up to 10, right? And this is actually a little bit awkward. So I'm going from 60 up and across to 10. That's a dot there, okay? Then at a price of 5, quantity demanded is higher, it's 80. So from 80 here, I go up, just carefully, and then go across, and there's a dot there. Now it is linear, so if I've made a mistake, this won't be a straight line. And then at a price of 15, the quantity demanded is 40. So I'm going up from 40, making sure I'm going along the right line here. All right, and I think that's 15 there. If I put my ruler down, draw, don't do what I do, remember, do what I say. And I'm telling you to draw this with a pencil, not with a pen. And that there is the demand curve, okay? That is a linear relationship, okay? Showing all the different combinations of price and quantity demanded for this function, this linear demand function, which in question 6 was 100 minus 4p. Guys, I'm going to stop it there and I'll take up the rest of the questions in the next video.